Okay, so let's have a sample problem for step-down chopper with an RL load. Okay, so a DC to DC chopper has an inductive load of 1 ohm resistance and 10 millihenry inductance. The source voltage is 24 volt. The frequency of the chopper is set to 100 Hz and the on time is 5 milliseconds. Determine the average, maximum, and minimum load currents. Okay, so I think yung pinakamadali natin pwedeng kunin dito is the average current or the DC current. Okay? Huwag kayong malilito, no? Pag may nakita kayong AVE, is just equal lang yan sa IDC, no? Parehas lang yung average value sa DC value. Okay? So, equal sa VAVE over R. So, yung average voltage natin for step-down chopper with an RL load is T on over T, which is the duty cycle, times input voltage over R. So, TO natin is 5 millisecond. And yung period natin, since yung given is frequency, 1 over 100 Hz yung ilalagay natin. Okay, so 24 volt divided by 1 ohm equal siya sa 12 ampere. Okay, so madali lang. Okay, next, yung maximum and minimum load currents. Ito, medyo may konting circuit analysis na involved dito. No? So, ang kailangan natin dito, obviously, is the two current equation or current function equation. So, dun muna tayo sa on time or current during on period. So, I of t, so this is during on time. Okay. So, I of t equals V out over R minus V out over R minus initial current e to the negative R over L T. Okay. So, ano yung ilalagay namin dito, sir? No? Baka yung iba magtanong sa inyo, ano po yung output voltage? Is it the VDC po ba? Or the 24 volt? Okay? Is it the average voltage or the 24 volt? Kasi yan lang naman dalawang pagpipilian. No? So, ang sagot ko is source voltage. Okay, bakit? Dahil on time yung pinag-uusapan natin, no? I-analyze natin yung circuit during on time. Okay, during on time, si SCR or si chopper switch is magko-close. Current will flow from input papunta dito sa node na to. So, since mataas ang polarity sa taas, si flywheel diode ay mag-open. So, si current dediretso sa load. Okay? Okay, pabalik of course dun sa input natin. So, ito yung output natin. So, magkakaroon ng output voltage. Okay? So, yung output voltage natin ay, kung mapapansin nyo, is parallel lang doon sa input natin na source. So, yung output natin is yung input natin. So, V out is equals to input voltage source. Okay? So, ilalagay natin dito na value is the 24 volt. Okay? I hope na gets yung part na yun. So, 24 over 1 minus 24 over 1 minus initial current e to the negative 1 over 10 millihenry times 5 millisecond. So, this is I of t. So, 24, konting simplify muna natin, no, para hindi tayo mahirapan. So, ito, simplify muna natin to. So, e to the negative 1 over 10 millihenry times 5 millisecond times 24. So, this is 14.556 minus or sorry, this is plus pala, no, kasi naka-parenthesis siya, no? 0.607 IO. Okay? So, simplify pa natin further. 14.556 9.444 plus 0.607 IO. Okay, so ano yung ilalagay natin dito sa I of t? Okay, dahil on time tayo, ang ilalagay natin dito, no, after 5 millisecond, from 0 to 5 millisecond. So, i-drawing ko sa inyo yung, yung output waveform nung current. So, yung current natin, of course, meron niyang initial current na I0 or I mean or I initial, okay? So, magkakaroon niya ng konting transient and ma-reach niya yung I final or I max. Okay? And then, babalik ulit yan, magde-decay yan exponentially, pabalik dun sa initial current natin. So, itong part na to is the T-on or the 5 millisecond. So, this is 0 to 5 millisecond and kunin natin pala yung final, no? I think meron naman ata tayong duty cycle. So, yung duty cycle natin dito is D is equals to 5 millisecond divided by the period. So, yung period natin ay 1 over 100 Hertz. So, I think this is 50%, 0.5 times 100. So, 0.5 na, no? So, 50% yung duty cycle natin. So, kung 50% yung duty cycle natin, kung yung on time natin is 5 millisecond, yung off time din natin is 5 millisecond din. So, from 0 to 5, this is the on. And from 5 millisecond to 10 millisecond, so ito naman yung off, T-off natin. So, yung T-off natin ay 10 millisecond minus 5 millisecond is 5 millisecond din. Okay? If that makes sense. Okay, sana na-gets yung part na yun. Okay, so yan, makakatulong tong output waveform na to sa pagsusolve natin. No? So, yung I of t natin, from 0 to 5 millisecond, yung I of t natin is, ilalagay ko siya as I max or I final. Okay, so itong expression na to ay I final. Okay? So, kailangan pa natin ng isa pang equation obviously, no? Kasi, hindi natin makukuha to kasi meron tayong unknown variable na initial current. So, kailangan natin yung isa pang equation which is the current equation during off time naman. So, I of t is equals to I final e to the, diretso ko na, no? E to the negative RL over t lang din naman yan, no? 1 over 10 millihenry times 5 millisecond. Yung 5 millisecond ilalagay nyo dito is the off time, no? Kaya lang 5 millisecond yung nilagay natin dito, it's because the duty cycle is 50%. If 60% yan or 70% or 90%, of course, hindi 5 millisecond yung ilalagay nyo dyan, no? So, kailangan nyo pa rin mag-solve. Okay? So, E 1 over 10 millihenry times 5 millisecond. So, I final 0.607. So, ano yung ilalagay natin sa I of t? So, since pinag-uusapan na natin dito is off period na or off or during off time. So, tingnan natin yung graph, no? Ano ba yung value niya at 10 millisecond? Okay? So, at 10 millisecond, of course, bumalik na siya dun sa initial current natin. So, ang value ng I of t natin after 5 millisecond ulit is the initial current or I0. Okay? So, meron na tayong equation 2. Meron tayong equation 1. So, pwede tayong mag-solve. No? Simultaneously na lang naman to. Hindi na kailangan ng mga determinants. So, i-substitute na lang natin to. So, I final is equals to 9.444 plus 0.607. I final 0.607. Okay? So, sagot natin for I final. So, pwede kayong mag-shift solve, no? Kung kaya ng calculator. No? So, try kong mag-shift solve kung kaya. 944.607 times 0.607 times x. Shift solve natin. So, ang sagot sa I final ay 14.95 ampere. Okay? And for the initial current or the minimum current is, times lang natin ng 0.607, ang sagot is 9.08 ampere. Okay, so this is the initial or I/O. Ito yung final natin na current. Okay? So, ito yung max current natin. Ito yung mean current natin. Okay? So, kailangan nyo lang talaga ng konting circuit analysis and konting algebra. So, yun. Makakatulong sa inyo. And of course, ito palang current output waveform, no? Para masagutan nyo rin yung problem, no? So, sana may natutunan kayo and as always, thank you for listening and God bless.